Let's do another problem from your homework set. This one asks us to evaluate the integral by reversing the order of integration. Now when you first look at this and you try to imagine how to integrate e to the x to the fourth power, there's no formula for that. We don't have a closed form formula for that. So we're going to need to reverse the order if we have a chance of solving for this. Now, even if we reverse the order, sometimes you still won't be able to integrate, and so we're kind of stuck. But these problems are set up for you so that reversing the order would allow you to actually compute the integral. So what we need to do is we need to look at the limits for x. This is your inner integral, and then the limits for y, your outer integral, as it stands in the beginning. So we're kind of working backwards here. We have the third root of y, and then the upper limit is 2, and then the y goes from 0 to 8. Now the next thing to do is, for me at least, I would want to graph this in 2 dimensions to get a visual of this. And so I need to graph this relationship. X is equal to the cube root of y. Now I could pull out Desmos for this, but let's try to do it without the computer. So this is equivalent to y is equal to x cubed, which is should be a familiar graph for most of us. Whoa, I don't know what happened there. Uh-oh, here we go again. We're having issues in my computer. There we go. Just have to draw it fast. And alright, so that's one of them. And then, so the x goes from there, and then x is equal to 2 is here, and so you probably would guess that the intersection here is 8. It's not always going to be, but in this case it is. And so you're going to go from x. So according to this, you're integrating with respect to x first, and you're going to be inside of the region here, and then you're going to come out of the region when x is equal to 2. And then your y goes from 0 to 8. So now we want to reverse the order, which means with the same drawing, I want to integrate with respect to y first. So I would draw a line parallel to the y-axis in and out of the region. So then my y limits are going to go first. My x limits will be constants, and you'll probably see that's going to be just 0 to 2, but let's figure out the x first. X is going to come in here at 0, and then, or the y is going to come in here at 0, and then it's going to get out of the region at this function, and we had already solved for y in this case, so we know that this is going to be x cubed. And then your x limits are just going to go from 0 to 2. Okay, so let's write this integral and see if we have any hopes for solving it. We have the integrand. Your integrand is 3e to the x to the fourth, and we're going to integrate with respect to y first, dy, and our y limits are going to go from 0 to x cubed. And then we're going to integrate with respect to x, and our x limits are going to be 0 to 2. So this, first, with respect to y, this is all constant, right? So it would be 3e to the x fourth times the y variable, and we're going to evaluate the y variable from 0 to x cubed. So the 0 will go away. It'll be 3e to the x to the fourth times x cubed, and you can see that this is a total setup for a u substitution. We integrate from 0 to 2 of 3e to the x to the fourth times x to the third dx, and then if if we let u equal to x to the fourth, we will get du equals 4x to the third dx. So x to the third dx is here. We have a constant of 4 that we can divide out, and we could take that 3 out also. So that's 3/4 integrate from, oops, let's figure out our changing limits. If x is equal to 2, the upper limit, 2 times 2 times 2 times 2 is 16. And if x is equal to 0, then 0 to the fourth is 0. So our lower limit is 0, upper limit is 16. We took the constants out already. We have e to the u, and then du. So we have 3/4 integral. Oops, let's not do the integral anymore, because the integral is e to the u from 0 to 16. So this is 3/4 e to the 16 minus e to the 0 is equal to 1. So I think that would be good. Alright, so that's all there is to it. No need to graph. I mean, you can graph this if you want, but it's not a big deal. But that's all it wants. Okay, I hope that helps.